All right, the first problem that we're going to do in the video is going to be number 21. Find two positive integers. So we have positive integers. So remember, an integer is a positive or negative counting number, including 0, but 0 is not positive. So if we've got positive integers, we're going to restrict our domain, which we'll do in a second. So in my case, find two positive integers such that their sum is 52. So I've got x plus y is 52. And if I want positive integers, that means my domain is from 1 to 51. Okay? So 1 could be x, 51 could be y, or y could be 1 and 51 could be x. My calculus side says that I want to maximize or minimize the sum of the squares. So if I've got x squared plus y squared needs to give me a min or a max. Okay, so what I can do from here is come back over to algebra and solve for one of the variables. So I'm going to choose to solve for y. So y is 52 minus x. And then I'm going to take that and I'm going to plug it in for y over here. So I've got x squared plus y squared, which is 52 minus x squared, is a min or a max. And then I'm going to go ahead and expand this out and combine like terms. So I have x squared plus 52 squared is 2704. Minus 104x plus x squared is a min or a max. So combining like terms, I've got 2x squared minus 104x plus 2704 equals a min or a max. So now it's ready for me to take a derivative. So my derivative is going to be 4x minus 104 equals 0. So add 104 to both sides. And I get 4x is 104, so divide both sides by 4, and I get x is 26. Okay? So if x is 26, come back over to algebra. 26 plus y is 52. Subtract 26 from both sides, and we get y is 26 as well. So is that a max or a min for the sum of squares? So if I do 26 squared plus 26 squared, I get 1352. Okay, so when x and y are both 26, I get 1352. So now I want to try my endpoints. Remember from the beginning part of this section, you always check your endpoints. So if x is 1, 1 squared plus 51 squared would be 1 plus 51 squared is 2602. Okay. So what I end up having here is that this is my min when x and y are both 26. And then my max is when one of them is 1 and one of them is 51. So my max is at 1 and 51. Okay? All right, I have a picture of a window. So a window is composed of a semicircle placed on top of a rectangle. If I've got 30 feet of window framing materials for the frame, which is all around the rectangle and all around the semicircle, what is the maximum size of window that we can create? So my algebra is going to be, this is going to be y. So what I have is I've got this portion and this portion, which are both r. I've got this portion and that portion, which are both r's. So I've got 4 r's So 4 r's plus 2 y's, this y and this y, plus I've got another 2 r's that are the base of the semicircle, so another 2 r's, plus how do I find the circumference of the circle? And remember, I only want half of it. So half of 2 pi r gives me just pi r. Okay, because the 1/2 and the 2 reduce. So I'll have plus pi r needs to give me 30. So I'm going to erase this part so I have room to write. So the calculus side is the area needs to be maximized. So for calculus, what I have is the area of the rectangle is 2r y. So an r plus an r times y. And then the area of half of a circle is 1/2 pi r squared. And that needs to be maximized. Okay, so I'm going to add all my like terms together here. This gives me 6 r's. So 6r plus 2r plus 2y. 6r plus, nope, sorry, just messed that up. 6 r's plus 2 y's plus a pi r equals a 30. Okay, and it's going to be easier for me to solve for y on this. So I'm going to solve for y by subtracting 6r and pi r from both sides. So I get 2y is 30 minus 6r minus pi r. Divide both sides by 2, and I get y equals 30 minus 6r minus pi r all over 2. Okay, so now I know what y is. So I'm not going to have enough room to write this, so I'm going to write it down here. Normally I would continue in the calculus column, but these are a little bit longer. So I'm going to substitute this in for y right here. So that gives me, so this is calculus. I have 2ry, so 2r times my y is actually 30 minus 6r minus pi r over 2 plus 1/2 pi r squared equals a max. Okay, so this 2 and this 2 reduce. And I'm going to distribute this r into here. So that gives me 30r minus 6r squared minus pi r squared plus 1/2 pi r squared equals a max. So negative pi r squared plus 1/2 pi r squared is negative 1/2 pi r squared. So I have 30r minus 6r squared minus 1/2 pi r squared is a max. And now I'm ready to take a derivative. So the derivative of 30r is 30 minus 12r minus pi r. So this 2 drops down and reduces with a 1/2. And that's going to be equal to 0. So I'm going to subtract 30 from both sides. And then I can divide. Let's see if you can see a little bit better. I can divide both sides, or not divide, I can divide out an r. So what I have is a negative 12r minus pi r. Negative, I don't know what I just said. Hang on. Negative 12r minus pi r equals negative 30. So I'm going to take that, and I'm going to factor out an r here. Remember, pi is a number. Okay, so if pi is a number, Let me focus that a little bit more. Hang on. It's old. It's going to take a second. All right. So I've got r negative 12 minus pi is negative 30. So divide by both sides by negative 12 minus pi. And all the negatives cancel. Good heavens, that's horrible. I'm sorry. Give me just a second. All right. So that gives us 30 over 12 plus pi. Okay, so now you know what r is, and now you can backtrack and figure out what y is. So y, what was y? Y is 30 minus 6r minus pi r. 30 minus 6r minus pi r all over 2. So plug your r into here, and then you'll know what y is, and you can find the dimensions of the window.